Okay, so with the kidneys, it's a lot of microscopic anatomy. So to get us there, I want to work through larger gross anatomy first. And gross anatomy meaning large, you can see it without a microscope, not like, ew, it's slimy, although it is. So we'll start with larger, and then we'll work our way to smaller towards the microscopic stuff throughout this model. All right, so let's go ahead and take a look at our kidney over here. With our kidney, we're going to protect it with a capsule around it made out of dense, regular connective tissue. So this is our fibrous capsule, or our renal capsule. The reason why we're going to bulk this one up is out of all of the really important organs that we have in the abdomen, this is the one that doesn't get into the peritoneal cavity. So all of your other abdominal organs get to be inside of a serous membrane that has a layer of serous fluid to protect it. This is actually behind that. So the location of the kidneys is what we call retroperitoneal. So we have to protect it with this capsule and also a layer of fat, which we call a fat pad. I don't know, I thought it was a cool name. If we're remembering some things that we've already studied at one point this semester, hanging out top here, the little party hat of the kidneys was the adrenal gland. This is an endocrine structure. So that gives us an orientation to superior here, inferior here. Medial side here, because this is going to be where you have the renal artery coming in and then the renal vein draining. The job of the kidney is to get a sample of the blood and then adjust that sample based on homeostatic need. So we'll have sample arriving through the renal artery. Then we're going to split into segments so we can go to different parts of the kidney. Then we're going to go up in between. Do you see how there's a repeating pattern here of pyramids? So these are pyramids, the ones with the stripes, and then columns are in between. So the interlobars are going to go up the columns. Up top here, this looks different. This is the cortex. So medulla on the inside, cortex on the outside. We're going to arch over top of that pyramid with an arcuate. So it's telling you it's arching. So we went renal artery, segmental, interlobar, arcuate. Once we arch, we're going to radiate out in the cortex. So this is cortical radiate. And this is when I'm going to start to switch over to our zoomed in version. So here's one pyramid. There's that interlobar artery. There's our arcuate. Here is a cortical radiate artery. From the cortical radiate artery, we're going to branch towards the area where we're going to get that sample taken. Now, to do that sampling, you have to have a specialized capillary that has holes in it. Those are called fenestrated capillaries. The specific ones that you find in the kidney are called the glomeruli. So the glomerulus is going to be in here to allow us to get our sample. So I'm going to shift us again to see a glomerulus. So that's what this is. So here's our glomerulus. That's that fancy capillary. We left off in our last picture with the cortical radiate leading you up the cortex. Once you go up, then you got to branch over towards these capillaries. So we're going to have an afferent arteriole going into this capillary. Then we're going to leave through an efferent. So A going in, E coming out or exit. So A before E. Now another thing to notice about this is the afferent arteriole is a lot wider in diameter than the efferent, which basically allows us to have higher hydrostatic pressure inside of this capillary. These molecules are going to collide into each other, and it's going to force them out into this bowl-like structure that will catch that sample. As I mentioned before, this is a fenestrated capillary, meaning it has pores and holes. We also put fancy cells over the top that look like they have little feet. These are called podocytes. So what they'll do is they reach over and create these little gaps in between each other around that capillary. Those gaps are called filtration slits. What goes through the filtration slit is all called filtrate. So the filtrate is going to be collected by this bowl, which is called the Bowman's capsule or glomerular capsule. Anything that goes into this fluid will need to be adjusted because it was based on size, not on need by the body. So if it was small enough to get through those fenestrations, those pores, and the filtration slit, it could end up in that sample. So you'll have a lot of water, but you also have a lot of things that we might want to keep, like glucose. So we're going to put it through, I like to think of it as a conveyor belt, but we're going to put it through nephron tubules. The nephron is the functional unit of the kidney. It includes this part where we get the sample and then the tubes where you can make adjustments. We're going to go back over to our medium-sized part of our model here. All right, so a recap of where we were. We were up here at that glomerulus getting our sample. So we had our cortical radiate artery, then we took an afferent arteriole, dropped off our sample at that glomerulus. Efferent will leave. We'll actually keep some of these capillaries nearby so we can make adjustments. You'll see some staying out here in the cortex, some coming down here into the pyramid. Now, once we have that sample, let's follow this one because it shows the whole thing. So we get our sample, the filtrate, we collect it by the Bowman's capsule or glomerular capsule, and then we're going to go into this first tube that twists and turns. It's close to the beginning, so this is the proximal convoluted tubule. So we'll twist and turn. Again, notice that we keep capillaries nearby. That allows us to bring things back into the bloodstream that we do want to keep, like glucose. We call that reabsorption. We'll dip down into the pyramid through what we call a nephron loop. We have a descending portion, then an ascending portion. On the descending portion, you will reabsorb water. On the ascending portion, you will reabsorb salt. As we come back up, we'll twist and turn again. So we'll call that the distal convoluted tubule because they're further away. From there, you'll go through a collecting tubule to a collecting duct. And through that collecting duct, you're going to go through the pyramid. So if you remember back all the way at the beginning, I said there's stripes in these pyramids. It's because you have a lot of collecting ducts that are all going to merge at the tip of the pyramid. The tip here is called the papilla. Papilla is a generic term, means nipple-like structure. So we'll have the papillary duct is the last part here where we're collecting. And we'll go through the renal papilla to then enter what we call a minor calyx. We're going to go back to the bigger stuff here. So we're going to go down the pyramids here, through the renal papilla, into the minor calyx. Calyces are plural, and those are going to be the first funnels. Then we're going to merge a couple of those minor calyxes to make a major calyx. Major calyces will come together to make a renal pelvis. Renal pelvis is the last funnel of the kidney that'll take us towards the ureter. Ureter is the tube that takes you to the urinary bladder to be stored, and then you exit from the urinary bladder out the urethra towards, hopefully, the toilet. And that's the basics for how the urinary system is going to function and its anatomy.